We're going to take a little digression from our discussion of multiplying polynomials to talk about something called special products. And special products are still multiplying polynomials, but it's multiplying polynomials that have shortcuts. And the first type of special product we're going to look at is something called the square of a sum. And that is when we have a binomial that is being added, like 7z plus 2, and then it's being squared. So what squared means is not 7 squared plus 2 squared. So let's get that out of the way right off the bat. This does not mean 7 squared plus 2 squared. That is incorrect. When you have something squared, what it means is multiply it by itself. So this means 7z plus 2 times 7z plus 2. Now we could solve this using our traditional multiplication techniques, which is just using the distributive property. So let's do it the long way first and see if we can figure out what the shortcut is. So the long way would be 7z times 7z, which is 49z squared, and then 7z times 2, which is 14z. And then we could do 2 times 7z, which is 14z, and then 2 times 2, which is 4. And then the last thing we do is combine the two terms in the middle. The 14z and the 14z added together gives us 28z right here. So our final answer is 49z squared plus 28z plus 4. Okay, so let's see if we can figure out the shortcut. Now what I said right at the beginning was this is not equal to 7z squared plus 2 squared, and it's not. But 7z squared is 49z squared, and 2 squared is 4. So if I had incorrectly done 7z squared plus 2 squared, again, that's incorrect, but if I had done that, I would have gotten the first term and the last term. The first term and the last term was 7z squared plus 2 squared. I would have only been missing the term in the middle, which was 28z. And it turns out there's a way to get 28z from the original sum of the square also, which is that we could have done 7z times 2 and then doubled that. So we could have taken the two terms, multiplied them together, and then doubled it. And so the way that this formula looks, if we were to write this out as a sort of, I guess, official math formula, it's if you have a binomial added together and squared, the shortcut is you take the first term and square it. On the end, you have the last term squared. And in the middle, you multiply the two terms together and then multiply by 2. So let's try this with 3x plus 2 squared, our second square of a sum here. So in this case, let's first identify what a and b are. A is the first term, so a is going to be 3x, and b is the second term, so b is going to be 2. And if we follow our format, our a plus b squared formula that I just wrote down here, let's follow this guy. We take the first term and we square it. So our first term was 3x. We're going to do 3x and we're going to square it. And then at the end, we're going to take our b, our last term, and we're going to square it. So plus 2 squared. And in the middle, we do plus our first term times our last term doubled. First term times last term times 2. And this is our shortcut. So 3x squared is 9x squared. 2 times 3x times 2, we do 2 times 3x, which is 6x, And 6x times 2 is 12x. And then on the end, 2 squared is 4. And there's our solution. So this is a shortcut. This a plus b squared that I highlighted in the lower left corner, that's a shortcut. If you're looking at that shortcut and you're thinking to yourself, shortcut seems really confusing or it doesn't seem short enough to be worth my while, you can always solve this by just writing it out twice and using standard distributive property. This is just another way to do it when it's a square of a sum. When you have a sum of two terms that's being squared, this is a way you can go straight to the answer rather than writing it out twice and doing the distributive property. So it's just another tool you have for how to get to the answer. It's not the only way to get to the answer. You can still do it the long way. This is just another way to get the answer.